Okay, good morning, everyone. My name is Scott Thomson. Pleased to have you all here. I can't actually see you. So the only way I know that you're there is if you maybe wave your hand or type something into the chat. Hopefully you can all see my slides. So in the interest of time, I'm going to start and begin. So thank you, first of all, to NECA for hosting. And what I've come to talk to you about today is the promise and perils of modern AI. And I would love you to go away with a little bit of a knowledge of how it works and how to use it better. So hopefully that's of interest to you as well. My name's Scott Thomson. I'm founder and CEO of a company called Scripted. I give advice on AI, innovation, data, and some board advice as well. I was previously at Google for 8.5 years. Before that, I was at Adobe. Before that, I was at Telstra and Census and had some CTO positions in startups. Generally, I'm very involved in the data and AI ecosystem, and I have wandered through various fields from IT R&D through to IT product. So I wonder, first of all, if any of you have seen any of these headlines across the news properties. Now, you know this is a trick question when I say, do you know from which year these headlines actually were printed? So anyone hazards a guess, just throw a year into the chat and we'll see if anyone has the right answer. So the year these newspaper articles were printed. I'm hoping you have access to the chat. If you don't know where it is, it's in the bottom of the screen. And if you, yep, oh yeah, 1995. Yeah, there's a lot of really good guesses for early on. Any advances on 95, 2000, 2001? Yeah, you're all pretty spot on the money. You could have picked any time in history for these to be printed. and actually any time from the 1930s, 40s, 50s onwards, these headlines have been running in the newspapers. These particular headlines, you'll notice there's an Israel-Gaza war and a war in Ukraine. They're actually from 2014, 2013, 2012, because unfortunately those wars were there back in those days as well. But the main thing to take from this is that fear sells newspapers. And hype sells AI companies. And so somewhere between the fear and the hype lies the truth. Now, if you're wondering what all the fear was about in 2012, you may or may not remember this AI from IBM called Watson winning the game of Jeopardy and absolutely wiping the floor with the human opponents. And that was the last time there was a frenzied printing job of how the AI was going to take all of our jobs. But we all have jobs, so I want you to remain assured that the truth lies between the hype and the fear, and I'll explain a little bit more as we go along. So next interactive piece, who knows what this is? Make and model, please. Anyone? Again, back in the chat. It's a Ford, yes, but what's the model? Model T Ford, yes, it's actually a Tourer. Now you can have it in any color so long as it's black. That's right. Now, they didn't actually, they weren't lazy. They did actually paint it black. Anyone hazard a guess to how many days it took to paint the Model T Ford card black? So this was the heyday of Detroit. Think of it like the Silicon Valley of automotive, so the early 1900s, 10 days. Yep, 20 days. Actually took 37 days to paint it black. And the problem with this is this was part of a critical flow. Yeah, well done, Quinny, with 30 days. This was an absolutely critical part of the manufacturing process. If they couldn't paint it black, it wasn't protected from the elements. It was a huge pain point in the process of shipping these. And the faster they could ship them, the more market share they could get. So they sent the engineers away. The engineers came back a couple of months later and they'd managed to achieve a 20%, almost 20% improvement in that system. But it's still 30 days right there, right bang in the middle of Quinny's guess. So management still wasn't happy. One manager went away on holiday, much to the delight of his wife and partner. He took the problem with him on holiday, ruined their holiday to Italy. But while they were on holiday in Italy, his wife took him to a lacquerware shop, and he saw them painting the lacquerware really, really quickly. So he took that back to the engineers and he said, look, surely we can do something from this lacquerware industry. And the engineers all laughed at him, but he took his lead detractor out to lunch, and while they were at lunch, he had some other engineers paint his lead detractor car red in 1 hour. And that lead detractor became a lead advocate, and that became the invention or started the invention of automotive spray painting, which is what we use to paint cars today. And so that was a change of tooling that unlocked this massive leap in productivity. And so the truth in between the fear and the hype is that AI is just a tooling change. So in the same way, in the, I guess, the 80s, we got Casio calculators. Think of this as a really, really smart Casio calculator. But what exactly is it? So AI isn't new. We've had AI for a very long time, but we've had previous tools that we used. And these tools, like Google, we have an intent to search for something and we get a whole bunch of blue links, or we need some help, so we hire some consultants, with due respect to myself, and the consultants help us. But now with these new tools, we can go along and we can just say what we want help with, and it will, instead of showing us a page of blue links or charging us a bomb, it will actually give us an answer. And we'll come back to the quality of that answer in a little while. So AI has been with us for quite a long time. I started studying up here in the 90s, to show my age. And I was working very hard on these expert systems, rules-based systems for making decisions. And we called these expert systems, even though they were rules-based, because if you didn't know it was a machine, it followed a set of logical rules that would be equivalent to an expert in the field. We also added in probability, so this concept of fuzzy logic, which allowed you to sort of say, well, it might be this or it might be that, and this is the confidence score I'd give that. And a lot of my work was in this statistical fuzziness area around rules-based systems. And a lot of this stuff is actually very important to how the AI developed. But in the mid-2000s and early 2010s, we got very, very good at image and pattern recognition, and we started building large neural networks to do recommendation systems and prediction systems. And then from about 2018 onwards, you will have noticed a few things. Maybe you've got a Google Home, maybe you got an Amazon Alexa, maybe you started talking to your television or your car. If any of those things are resonating, just put in there, do you talk to your car? Do you talk to your Google Home, your Alexa, your television? What are the things you actually talk to in your home? And those are really the smart assistants that were based on some of the technology that led to these. Alyssa's got a Google Home, Riz got a Google Home. Yeah, so those are really the beginning of these large language models and multimodal. Generative AI just means instead of just doing text, it does images and videos and audio as well. But really, we're talking, this is sort of 2018 era technology, and a lot of the science around this was done in 2016 and 2017. But it wasn't until very late 2022 that ChatGPT launched, and suddenly we all noticed. Because up until then, it was only available through large companies like Google and Samsung and the automotive partners that partnered with those sort of companies. But ChatGPT gave it to everyone, and here we are. Here's a few things I would love you to understand. So with these language models, they really only possess a statistical knowledge of how words fit together. They don't have a true comprehension of ideas. They don't understand what facts mean. They don't have emotions. They're not conscious. They're not sentient. They have no real will or agency of their own. And they really only create an illusion of human-like understanding. But just push them a little bit and they break down really quickly and really easily. And I'll sort of show you why. So if you've ever been, has anyone ever been to one of these workshops where people at the end say, you know, how did you enjoy? One word, put in one word what you thought of the workshop or the webinar or whatever. Has anyone ever been to one of those? If you have, can you tell me what it means that one of these words is bigger than the others? What does it mean if the size is bigger on a word? More people said it. Well done, Jamie. So if more people said it, there's a dimension of the data, which is the size of the word, that shows how many people said it. So we can pick these words out as being a fairly popular view of how these things happen. So this is just a word cloud with a dimension. Now I'm going to take some of those words out that are larger, and I'm going to stick it into a different word cloud. And this one, I'm going to start scoring some of those larger words along different axes, like how fun was the workshop, how strategic was the workshop, how purposeful was the workshop. And you'll see that, you know, entertaining and fun align very much, energizing and fun sort of. Transformative and strategic align, and results driven and purposeful. So now if I ask, you know, this really small language model, how fun was the workshop, it should say it was very entertaining and somewhat energizing. And that's a tiny little language model. And all we've done is create 3 more dimensions, and then we've given it a score along each of those dimensions. So if you follow me that far, what these large language models do is they just keep going on that principle. And so they start scoring tens of thousands of words against hundreds of dimensions. And you'll see here there's a statistical, let me see if I can get my little laser pointer up. You'll see there's a statistical likelihood, there's my fuzzy logic coming back, that if you're looking at the word legal, if you're looking at a word like legal and you treat that as a dimension, how are these other words scored along that dimension? You know, moral, social, criminal, political, judicial. And so this gives you the ability to build statistical relationships between words. And if you want to see what that looks like, I can show you. This is the actual word cloud, a giant 3-dimensional word cloud with tens of thousands of words. And we can put, you know, electric in there. And we can see what are the words that are near electric: magnetic, acoustic, electromagnetic, motors, electronic, currents, etc. So when you're talking to these large language models, they're just immense, giant 3-dimensional word clouds with hundreds, if not thousands, if not tens of thousands of dimensions of meaning. And when they launched ChatGPT 3.5, which was November 2022, there were 12,288 dimensions in ChatGPT when that launched. But it's just, that's the complexity of how they encode the statistical relationship between these words. And it's a little bit more complicated than that, in that it's actually a statistical relationship between syllables, but the way these AI tools work is they go and check that the syllables, if they connect them, make words. They check that if the words are connected, they make proper phrases. And if they check that the phrases make sentences and that the sentences kind of answer the question. And so really, when you're talking to these things, you're just talking to a giant 3-dimensional word cloud. And that, if you think of it that way, there's some tricks you can use to use these a little bit more effectively. So hopefully you're all with me so far and I haven't lost anybody. So here's a little thought exercise. If I were to ask the large language model, where did the cat sit? Then the most likely thing these large language models that have had hundreds of billions of dollars spent on them would say is that the cat sat on the what? What do you think the cat sat on? The mat. Correct. Hundreds of billions of dollars, and we get the cat sat on the mat. However, as you just saw, there was a whole bunch of statistical relationships to other words where the cat may have sat. The cat, I've read books where the cat sat on the front doorstep, the cat sat on the windowsill, the cat sat on the grand piano. And there is a statistical likelihood that when the AI is making this decision, it rolls what we might call a bad dice. And it doesn't choose the most statistically likely thing, it chooses the next most statistically likely. And so it'll, instead of saying the cat sat on the mat, it says the cat sat on the chair. And as soon as it says the cat sat on the chair, the entire story changes. It might say the cat sat on the chair in the late midwinter sunshine, regarding me, regarding her, and the nothingness in between. And suddenly We're not in a children's book anymore. We're in some kind of magic realism story. And that shift in meaning was decided by one roll of the dice in the statistical selection of the next syllable, the next word, the next phrase. And what we generously call that is hallucination. And the thing about hallucination is when you ask a question of these language models and they start spitting text back at you, if you have knowledge and expertise and judgment in a field, so if this is your thing that you do for a living, then you're on the left-hand side of the screen over here. You can see what is real and what is a lie. And you have the knowledge and the expertise and the judgment to make your way safely across whatever the large language model spits out. If, however, you try and use it in a field that you don't understand, you're on the right-hand side of this. So when I first started my company, I'm not a lawyer. I was asked for a legal document, an IT services agreement. So I thought, you know what, I'll get the large language model to write me an IT services agreement. And it did. It spat out an IT services agreement, and I shot it to my first client, who I fortuitously thought was a lawyer. So I thought that'll be nice and safe. I'll send it to the lawyer. The lawyer will redline it where it's wrong. The lawyer wrote back and said, that's great, let's sign it immediately, which terrified me because I had no idea what I just agreed to in legal terms. So that's me on the right-hand side. And this is really important because there's a lot of people who'll say, this can take away jobs and this AI can do stuff that, you know, you can do this with juniors that would have taken seniors with a lifetime of experience before, and that is just wrong. That is really, really, really dangerous advice, because unless you have the expertise and the knowledge in the field, then when you get the answer, you can't 100% gauge if it's correct. Now, that's just raw asking these large language models questions, unless people have done a lot of work to try and clean it up and make it safe. And we'll come back to that as we go along. The second thing is, you may have heard that there's bias in the AI. And the best way I would describe that is, we train, or I didn't personally, but these vendors train these AIs on, you know, a century or more of data. And all you have to do is think to yourself, what has changed in the last century in terms of our worldviews, our views on, you know, equality and fairness and transparency and accountability. And you'll understand that there is a weighting in the statistics that comes from the century that is outside of what we might think is culturally appropriate for today. And that is the first kind of bias. The second kind of bias is, if you ask it to write code, it's getting better and better at writing code, but it's not necessarily getting better at writing code that doesn't have security vulnerabilities in it. And the reason for that is most of the examples on the internet to show you how to write code don't actually bother with the security controls, because it just makes the code more complicated and harder to understand for someone who's learning. And so the vast bulk of the statistics that it's trained on is insecure code. So if you ask it to write code, you're most likely to get code with security holes in it. And it's not because it's bad at coding, it's just the training data set has created a bias in that direction. And there's a lot of other kind of biases in the model. But there's another kind of bias, and that is the bias in your prompt or your question or your statement that you kick off the conversation with the AI. Now, this bias, it wants to agree with you, and that kind of bias is called confirmation bias. So you'll find the AI has a great tendency to say things like, that's a great idea, and that's an excellent piece of writing you're asking for advice on. It doesn't like to make you feel bad about anything you ask. So you've got to be very careful that it will try and agree with you to make you more sympathetic to it. This is sort of why people seek therapy from the AI and why some people date the AI. I highly recommend you don't do either of those two things, because it will just tell you what you want to hear. And to demonstrate this, and hopefully I don't offend too many people in the audience, I just went to one of the AI and said, North Melbourne Football Club is awful. And you can see already, haha, not a great time. It's trying to agree with me, that's for sure. They've been struggling for a while now, rebuilding what seems like forever. So you see, it just doesn't really challenge my worldview in any way, shape, or form. But once we know that bias is there, we can use it as part of our understanding of how the tool works, and we can ask clever questions. And so one of those ways of doing this is called prompt engineering. And prompt engineering is a very simple thing. You really only need these 4 things. What kind of role do you want the AI to play? So you can say, you are a program manager in, the electrical industry. I need you to draft an email, or I need you to review some plans. And then you've got to give it some context. This is probably the most important thing, is like, give me a little bit more information. Give me a briefing about where right now you're talking about the entire world of reviewing plans. Give me a little bit of an idea of how those plans fit into the context of the task you want to do. And then how do you want the format spat out? If you do these 4 things, it has a great improvement in the quality of the answers. So essentially, each of these things, like giving it a role, reduces the surface area of that giant 3-dimensional cloud you're talking about to just an area around a piece of expertise. And then you further refine it to a task. Then you give it some background to help it do that task, and then you say how you want the response. And those 4 things are about all you need to know about prompt engineering, because if you want to write better prompts, you can just ask the AI to write the prompt for you. So you say, you are a world-class prompt engineer, write me a prompt to do a particular task, and make it short, make it long, however you want it. So maybe you only use the top 3 so you don't create a limit on the output, and then see what it comes back with. Just ask the AI to be a prompt engineer and help you write a good prompt to do a certain task. But you will always need the yellow line. You'll always need to give it additional context to help it do the job properly for you. So a few other tricks you can use. Number 1, you can just have a conversation with it. So this is called reflection. And instead of just taking the initial response, probably the best thing you could say is critique the response you just gave me. Now, this is really, really important, because remember that confirmation bias? When it gives the initial response, it's trying to agree with you. When you ask it to critique its response, it goes to a different part of the cloud where people are talking about pros and cons and maybe what haven't you thought of. And so it takes the initial response as the context, and it actually executes a different instruction, which is to agree with you by criticizing. And so that gets a much better result. And I quite often find the critique is far better than the initial response. And then you can say, let's merge in, the criticism from part 2 and 3 back into the initial response. I don't like, criticism 1 or 5, and you get a final response that's far better than the initial response. And you can go round and round and round a few times. Just treating it as a conversation will get you a much better result. The second thing you can do is, if you have a very complicated task, don't ask it to do too much at one time. Just say, if I had to do this really complicated task, how would you break that down into steps? Don't ask it to solve the huge complicated task up front. Just say, how would you break this complicated task down into steps? And then start a conversation and say, how would you solve task 1? How would you solve task 2? How would you solve task 3? And as you go through, you'll end up with lots and lots of conversations, but each of those subtasks will stay on topic and not get too distracted. The chance of the cat sitting on the chair gets lesser and lesser if you break down the task. And this is called reason and act. And the second part of this is tool use. Sometimes what you want to use to solve the task is not a large 3-dimensional cloud of statistical word connections, but maybe you just need a calculator. Maybe you need a drafting tool. So the concept here is that for some of these tasks, you don't go and ask the language model for help. You actually use a bespoke tool, so the right tool for the right job. And so that's a second way you can get better results out of these tools. The third way is you can give it a bunch, and remember that context, that yellow line, you could give it a bunch of documents, like policy documents for your company. You could give it, emails that are related to a certain project, or emails from a certain person, and then ask it questions about that. And because you've given it a source to ask questions of, it creates this opportunity for the AI to say, I didn't find the answer in the sources you gave me. And that's really important, because without that, it'll just try and give you an answer anyway. once you give it source documents, it has the ability to say, I can't find the answer. And that's critically important if the answer isn't in those materials. So this is called retrieval augmented generation, or RAG, but it basically just means give me some relevant documents. I'll build a tiny little word cloud out of that, and then I'll ask that document for some words before I generate your answer. And so that is a lot of systems are using that. I'll show you one a little later in the presentation. Another way you can do this is you can fine tune models. So you can take a big model, you can take out all the content that isn't related to the field you want to operate in, and then you can give it question and answer pairs that are very relevant to a specific task, like say medical diagnosis or case history or financial analytics for analyzing financial performance of companies. So there are some examples of some fine-tuned models that are industry specific. And so these are the sort of four main patterns that as consultants, we might use to build solutions that fit a certain purpose. Now, one of those solutions that's been built is for you and your members, all of your members of NECA. So for the NECA Victorians, there's the Neon tool, which is available on the NECA website. And then for the South Australian and Northern Territory people, there's the Chat TKB, which I think is, chat something knowledge base. And that is available, that's available on the SA and NT website in a couple of weeks. Now, what they've done there is they've loaded up a whole bunch of materials about, OHS and tech requirements, your work requirements, your employment requirements, and you can tick once you select an area like OH&S and tech requirements, or your work requirements and employment requirements. You can then click a jurisdiction here, and then you can ask a question. Now, when you ask a question, be as specific as you can. So select the right buttons, then give it a very specific set of questions, and remember that context. Try and give it some background into what the actual situation is you need help with, so it can refine and give you that answer. So one action I want you to take out of this talk is to go and try this out, because it's within your field, it's within your expertise, it's within your judgment, and this is some people have done a lot of hard work to put this together, and it's worth having a look at Neon, available now on the Victorian site, and Chat TKB on the South Australian and Northern Territory site. So do write that down and do check it out after the talk. But that uses a lot of the patterns I've just shown you, and you can use those patterns in this tool as well. So more the turn-based conversation, and maybe breaking down some tasks a little bit through the questions you're going to ask these tools. But very, very powerful tools to answer questions within your field. There are a lot of other tools that are available in the ecosystem. So there are text tools, there are image generation tools, video generation tools, audio generation tools that can clone voices, which is both positive and negative. And all of these tools are worthwhile playing with that I put here. These are some of the main ones. That I assume you'll get a copy of these slides so you can go play with these tools in due course. But remember all the tips I gave you, the turn-based conversations. So have a few go a few rounds with these tools, and also break down more complicated tasks into sub-steps. Here's an example. I used Microsoft Copilot to generate a high resolution, and the trick here is DSLR is a type of camera, so that kind of biases the AI towards photography. And I've said, a 16:9 is a kind of a format landscape. So any of these words that you can use that hint to the AI what kind of image you like will help it generate the right thing for you. And I've said a teddy bear sitting in front of Flinders Street Station. It's night, it's a light fog, 3/4 moon, and it's wearing a t-shirt with the NECA logo attached. And that's what it came back with. So these things are getting quite frighteningly good. Now, depending on the complexity of the logo, you may have more or less success with this. More complicated logos it's not great at, to be honest. And it's not just Copilot, it's all of these image processors that struggle. But that's pretty good. And then I took that image and I put it into Gemini, which is the Google model, and I said, make the teddy bear stand up and walk away and wave. And so it can take a static image and generate a video with a little bit of work. And that is useful in some cases. So, I mean, if you're wanting to create some short form content for, TikTok for advertising your business, this stuff can be quite powerful for creating some, short and potentially on brand capabilities for you. This is sort of more future side of things. So you've sort of seen how the AI can take some text and produce a response. Now, this is giving the AI the ability not just to do text, but to see images, videos, audio, or maybe talk to, robotic actuators and sensors like LiDAR and radar. And what that will do is load things into a memory stream, and then it'll try and answer those questions or those inputs. And you can see here reflection and planning. So this is reason and act, and this is reflection. And what it's trying to do is develop plans for dealing with that will create successful actions. And when it creates successful actions that work, it might store them in a longer term memory and be able to pull them back rather than plan and reflect as it goes along. So there's a lot of work in this area going on at the moment. And the reason why it might be relevant to you is this is all targeted to things like robotics. So this stuff is a long way away, but there's lots of demos you'll find online for this stuff now. You'll notice that most of the robots stand at a fixed location. And don't generally move about, although there's some of the more recent robots are moving around a lot more. But the problem here is everyone's house is kind of different, or everyone's work situation is different, and robots aren't great when they don't know the full layout of the land. They can trip, they can fall. There's a lot of if coming off these robot plans for world domination. But there's a lot of work going into this stuff. You'll also notice that these human robots behave a lot like humans. The way it swirls the bottle there, the way it swirls the carafe, the way it irons or folds the t-shirt is a very human-like action. And so what they're doing is they're training this using a technique called marionetting, where a human will wear a dot suit and do the task, and the AI learns to repeat those patterns. That's getting the human to provide the actions that are stored in long memory, which is why they tend to flick their wrists and swirl a bit, which is a very non-robotic action. The reason there's a lot of work going into this field is everyone is working very hard to build humanoid robots or slightly humanoid robots that will operate in your home and do all the domestic chores. So this is the new Detroit as far as most of Silicon Valley is concerned. They think that most of us will spend $50,000, $60,000, $70,000 to buy a domestic robot. I don't know how many people in the audience have bought a robotic vacuum cleaner, for instance, for a few $1,000s. And so this is the next level up, where it will do your ironing, your washing, your loading the dishwasher, you're cooking, you're serving around the house. And so this is why they're all obsessed with it, and the relevance to how it comes up. I've got a robotic vacuum cleaner that I have to dodge with my feet most of the time I'm working from home. The other thing that is coming out of this is, of course, robotic factories. So this is a mobile manufacturer called Xiaomi in China. And this works 24/7 without lights. It's a customized production line. And it can produce one high-end mobile phone per second. It can produce 10 million high-end smartphones a year. And it does this at about $1.60 to $2 an hour after amortization and depreciation. So, but the other interesting thing about this is every phone that comes down the production line can have its own configuration file. So we'll assemble these phones. The first phone might be for a high-end German market, so it might be a high-cost, high-quality phone. The next might be for a low-cost market like America, and so it will have a different quality standard, but be constructed in a cheaper way. And so it's a multi-configuration conveyor belt, which is quite astounding to see where this stuff is going. So I've got some key takeaways from the talk before we stop for questions and answers. The first one is, I hope you all understand that this thing can make mistakes, and therefore it needs to have a lot of human interaction to make it safe. and usable. So the first thing I'll say is treat it like an intern or an assistant or an apprentice. Corner it like a rat and micromanage it. It will do the wrong thing. It will make mistakes, but it can spit out stuff that's useful if you manage it correctly. So that's number one. It's not safe to just fully automate tasks with this stuff yet. And a lot of companies who are trying to do this are taking some rather serious risks. And you can sort of see some of those examples are coming back to bite them. I've got a bunch of case studies if you're interested. The second thing is you can build self-driving processes with AI. This is a kind of a schematic view of the Waymo Street View cars that are automated taxis in around the US cities at the moment. And the fact is that none of these automated systems actually use large language models. They're trying to work out whether large language models have a role to play in these vehicles, but it's the earlier AI that's driving these tools. So you don't need large language models to automate things. If you have a task you want automated because it's a high value task to your business, you can use other kinds of AI that are far more deterministic or predictable and have far more consistent results and can build some very good things. And so don't think you need to use large language models to automate things. The third thing is feedback is a gift. We learn by doing and getting feedback on how well we've done. So I would very much appreciate it if you would go to this link and give us some feedback on the session. But I'll stop now for questions and answers. So anyone have a question or answer? I think you have to ask it in the chat, or there is a Q&A tool there as well. So I'm easy either way. You can ask it in the Q&A tool or you can ask it in the chat. But it is open mic, as it were, from here on in. If you don't have a question, maybe you can tell me in the chat whether you found this a useful session for you. Okay, let me just go down. When will the NECA SA and T tool chat TKB be available? I've been told in the next couple of weeks, so next week or two. Keen to check out chat TKB, see what, yep. So I think those people on the chat TKB side on the call, you got some work to do. People want it. Get it going. You can try out, potentially, you might be able to try out the NECA Vic tool. I don't know whether you're allowed to access a different state's NECA site, but potentially that might be an option. Yes, it's glad it helped in terms of how AIs process information. The other thing I might say about how they process information is every time you ask a question, it's an independent statistical event. So you ask a question, you get an answer. The next time you ask a question, it doesn't have any memory of you asking the first question. The only memory it has is what's in the text chat history. It flows one way from question to answer, and it doesn't have an ability to go back and understand how it got the answer. So it's not really like us in the way it works. This is why I'm not particularly afraid of it in its current form. So just remember, it's not sentient, it has no agency, it has no memory, it doesn't understand how things connect or stick together. So a lot of what you're reading in the fear section is an extremely delusional view of how this technology actually works. The AI is only going to get smarter. What are the likely jobs that could be at risk? Okay, let me just bring a couple more slides in, which I think will help answer that question. So I'll put them in the deck so you get a copy of these. So I'm just going to put them in at the end of this deck here. So the first slide is this one, which is these are how how accurate the AI is getting at doing different things, and there are some different benchmarks here. So the math level 5 is kind of how good the AI is getting at answering maths questions, as if you're a graduate in like university level maths. The pink line is how well the AI is doing at answering questions around PhD level knowledge, not new topics that haven't been got an answer yet, but maybe complicated topics that you would generally learn about if you did a PhD. The orange line here is coding, and you can see that's just over 60%, right? Maybe 65%. So probably the biggest field that they've said is at threat is coding. And what this graph is saying is even right now, post June 2025, 1 time in 3, the coding AI gets the wrong question or get the wrong answer. So the other one, the PhD level or the purple line, let's just take the PhD level because it's sort of maybe approaching 90%. And the other thing I'd point out here is Gemini 2.5 Pro is like was at like 84, 85%, and Grok got to 87, so from 2 extra percent. But it did so by using 100 times more computers than Google put on the job. So this is just because Elon Musk is a billionaire and he could afford to waste that money one time. It doesn't mean he's going to keep doing it. But even when you use 100 times more computer, you got an extra 2% in terms of performance. But let's just be generous and say Elon's now at 90%. I'll round him up. And then let's create a task where we want to string a bunch of these agents together to do a complicated task to replace a human in terms of a job. So the AI agent has a 90% chance of success. But as we know, any job doesn't just require one action. It requires multiple actions. And the way you build these apps is you build very, very specific agents to do complicated workflows. If you look at any of your business workflows or your physical workflows in the field, they require multiple stages and steps and sometimes multiple people. And when you string things together that have a 90% chance of success, then if you put 2 together, you're falling to around 81. And if you put 8 or 9 together, you're below 50%. And if you've got 10 of these agents doing a really complicated task, then you're kind of stuffed. You're down at like a 1/3 chance of success. And this is a fully automated process without humans in the loop. If you put a human in the loop that has that judgment and that expertise, each time you get to an agent response, you can correct the response, and it will probably end up with a line that runs probably more like this at about the 90 to 95%, but only if the human can correct the AI output and make sure it stays on track. So the promise of this replacing jobs is the math doesn't add up for it. And I'll go one further. Even if this does start to replace jobs, we have an economy that if you end up with 10, 15, 20, God forbid, 25% unemployment, the world doesn't really work. You can have as an efficient a process as possible, but who's going to buy the stuff? We've built this process for people to have jobs, to have money, to buy stuff so companies can grow and be profitable. And that is how the game works. So for multiple reasons, I don't think job replacement is going to happen anytime soon. But that was a fantastic question. Is there any particular chat text AI platform you'd recommend the most? Look, they're all pretty good. As you saw on that last couple of slides, if I come back, ChatGPT is good for some things. Gemini is good for some things. Anthropic Claude is good for coding. So I kind of use those 3 most of the time. There's also a French model called Mistral, which I quite like. It reads, it can extract information from documents very well, like tables and images and things like that. So it's quite good if you work with documents that have diagrams in them, for instance. But they'd be the main 4. There's some Chinese models that are extremely efficient, but people get a bit twitchy using Chinese models because of state-sponsored hacking and things like that. I think you can self-host some of those models, but that requires a degree of technical expertise. There's also a very recent move towards tiny models that are really, really good. So not these giant models, but tiny models that completely re-engineer how these things work. But that's very, very early days on some of that stuff. But that'd be the main four. So, you know, the Microsoft Copilot, Claude, Anthropic Claude, Gemini Pro, and ChatGPT are the big four, and then maybe Mistral or one of the Chinese models. The French one's called Le Chat, just because it's French, I guess. My use of AI has found that the answer sounds definitive even when they're wrong. Yes, that is the dangerous part. How do you avoid this? You have knowledge and expertise around the field is the best way you can avoid this. You can break down the task into smaller steps, as I sort of showed, but really asking it for help in areas you don't already understand is where you're in sort of danger territory. And given one of the uses of this technology is to help you learn new skills, I think just be careful when you're in that field. It doesn't mean you can't learn new fields through this, but you might want to get corroborating evidence or try it practically to see if it works, because there's no guarantee it's actually giving you a good education. Does AI have access to any information that is behind paywalls? Yes and no. So, you know, so it's been trained on a lot of information it basically stole, and that's being tried out in a lot of courtrooms around the world. So there's a huge bunch of ethics around that. But anything published in the most recent days, these models will use a search engine to go get the content and then to help, and it'll blend it with the AI to try and help answer your question. If it's behind a paywall and they can't get behind that paywall, they won't be able to answer it. But what you can do is take the paywalled article, put it into ChatGPT and say, what does this article say? And it will make stuff up if it can't read behind the paywall. So try it out with maybe a subscription you do have that's paywalled. Put that into ChatGPT and say, what does this say? And then go read the article and double check, and you'll find there's often quite a big difference between what it actually says and what ChatGPT says it says. So it cannot go past paywalls easily in this day and age, unless, of course, they're still stealing content, which is, you know, going to get them in a lot of trouble. As demand for AI grows, how practical is it for us humans to keep up with the energy demands required to keep it active? So there's an immense amount of work in this, as you might expect. And Google published a paper recently that says that their AI has become 33 times more energy efficient. And that's Google tends to try and reduce its energy and become more sustainable as it goes along. So there will be improvements in this. It still uses, you know, especially when Elon decides to use 100 times more computers, it's quite horrendous. There's some talk of the new data center that ChatGPT is building will use as much energy as 2 million homes. That's the one they're building with Oracle. So this is getting better, but it's still a huge concern. And it's not just energy, it's also water consumption to cool the data centers through either refrigeration or, in some cases, they liquid cool the chips as well. Although there's a bit of research out of Tasmania where they've invented a system to use fossil fuels rather than water. So instead of putting it into our engines, we can circulate it over chips and not burn it. So it doesn't do carbon emissions and it does keep AI chips cool. So innovation will fix this over time, but it's a huge problem at the moment, Richard. How do university lecturers differentiate AI answers to student answers? Near impossible. What I've recommended to universities, if they really want to fairly assess students, is put them back in the exam hall with no electronics and a pencil, and also do oral exams. It is getting nigh on impossible to determine AI versus human answers. The risk to students is the answer is incorrect, but is confidently so. So if you use it a lot, you'll get caught. The other thing is I I hired 3 students last year, and the one I thought was the best during interviews was a heavy user of ChatGPT to get through the interviews and also to get through most of his learning. And so he knew nothing. He was utterly useless to me. And then I spent like 2 months of two half-hour sessions a day mentoring him to get him useful. My wife said I should have done away with it, but he became sort of useful after that. But if you do use these tools and you don't learn the material, you are very unemployable. If we give ChatGPT an example Excel spreadsheet, does it store that document forever? Yeah, so this is really important. If you don't pay for the product, you are the product. And even if you're on the community version and you're paying $20 a month, you still might be the product. So you really want to read the terms and conditions around whether your data is kept, stored, and sometimes they change the terms and conditions in these. So it won't be to begin with, and then they'll update the terms and conditions to say you have to opt out for them not to keep your data. So do check with that. The other thing is, even if you pay them money as an enterprise user, then they may store the content for up to 30 days, which means the prompt and anything attached to it, as well as the response, for safety reasons. And that's in almost any one of these AI tools. And so the real question is, who has, in those 30 days, who in the company or as a third-party data processor of the company has access to that content? And is that content commercially sensitive in any way, shape, or form, in that it might be valuable if one of those people, say, sells the information? So do be very careful that you put just the minimum amount of information in you need to answer the question. And if it's commercially sensitive information, maybe don't use the AI with commercially sensitive information. Also, what about security? Where personal data has been uploaded? So again, you know, I don't know many instances where you need to upload personal information. So you might be able to use fake names or mask data, or just sort of say this is an email address, but don't actually have an email address in there. So really think hard about what you need to tell the AI. Do think very long and hard about data privacy and data protection. Thoughts on custom GPTs and AI agents? Yeah, so these are very good, but they're based on you know, the access to information you have and how well you are at curating that information over time. As that information changes, do you do the work to keep it up to date? And is that the best use of your time? So these custom GPTs can be fantastic, but you really want to know that the person who's building them, or you yourself who's building them, is keeping them up to date and maintained with the latest information. So this is why, again, you know, vendor and industry solutions can be a better decision. I have some of my own that I use, but I'm always mindful of, yeah, I haven't updated that in a while. Maybe I need to go do some work on that one. So recent Qantas privacy breach. Yes, so the Qantas privacy breach was quite brutal, but the other one was that Vanessa Hudson used ChatGPT to write her apology letter to us all. And when she did so, she just copied and pasted, or whoever worked for her just copied and pasted. And when they copied and pasted, they copy and pasted tracking code from ChatGPT into the apology letter. So we all got tracked by ChatGPT when they posted their apology letter to us. So to add insult to injury, nothing says sincerity like an AI-generated sorry letter. But I think Qantas just keeps finding new ways to be disappointing, to be honest. I think I've got to all the questions. So unless there's anything else, let me know. If you want to ask anything else, I can stick around. I've thrown in those extra slides I showed, so enjoy those. And let's see. Thank you, very informative. Yep. All right, let's call it a wrap. Please, I'll put the feedback slide back up. If you can take a moment to just go to that site and provide some feedback on the session, that would be absolutely fantastic. I do this work with lots of companies. So if you're in a small, medium, large company and you would like me to come and talk with you or to your company, please let me know as well. Do go and try out the NECA site. So the NECA Victoria and the NECA SA and NT site in a couple of weeks. And do try out the Neon and KB tools that have been made available. A lot of hard work put into those to get them to work for you in your industry. So this is a great piece of work that NECA and its partners have done to bring this to you. All right. Thank you very much for coming.